This week we're going to be thinking about a special type of graph, which is called a distance time graph. Okay, and this graph shows how your movement varies over time. Okay, and you'll see how it works through an example. So we have to have an axis, and this will be our time along the x-axis and our distance along the y-axis. Okay, now normally we would do you're driving in a car or going to see your friend or going shopping or something. All right, but we're going to do a lockdown version. Okay, we're going to do a lockdown version of our distance time graph. Okay, which means that we can't go outside the house. So let's imagine that here, this is when you get up. All right, wake up. Okay, so when you wake up, the first thing you do is you need to go to the bathroom, have a wash, all right, that kind of thing. All right, so we're going to go like this. Okay, so you can see that at the very start, as time goes on, your distance is increasing because you are walking to the bathroom. Okay, so it takes you this much time to walk to the bathroom and it's this much distance. All right, let's say this is from your bedroom to your bathroom, 10 meters. Okay, now you're in the bathroom and you're having a wash, that kind of thing. You're not moving. Okay, you stand in front of the mirror, you brush your teeth. All right, so while you're doing that, time is going on, but you're not moving. So it looks like that. All right, so here we are wash, brush teeth, okay, that kind of thing. Okay, now once we've done that, we're going to go downstairs for breakfast. Okay, now you've probably got something delicious, nice bowl of Cocoa Pops or something, so you're really excited. All right, and the kitchen is downstairs. Let's say it's 15 meters from the bathroom, so that's going to be 25 meters. Now you're so excited about the Cocoa Pops, you're going to really rush down there. So that's going to take you no time at all. Okay, so that's going to be really quick. All right, thundering down those stairs. Okay, into the kitchen. All right, and you get those Cocoa Pops, and then you're going to sit and you're going to really enjoy those Cocoa Pops. Now, while you're doing that, you're not going to move. All right, you're just going to sit down at the kitchen table, and you're going to really enjoy those Cocoa Pops. So that's you eating breakfast. Yeah, so time is going on, but you're not moving, so your distance doesn't change. Okay, and that's eating breakfast. Okay, now once you've done breakfast, next task is obviously go to your computer, log on to Firefly and see what exciting work Mr. Dwyer has set you for science. All right, so let's say that to get from your kitchen to your living room, that's another 10 meters, so that's 35 meters. All right, but then you remember that today it's not science. All right, so you're just a bit disappointed about that, so you just sort of take your time. Okay, so you sort of go a little bit slowly because you're thinking, oh, I wish it was science today. All right, so you're going to take your time when you're doing that. And you get there. All right, so you're going to see how here you're really quick. Didn't take you any time at all. Whereas here you're a little bit slower. All right, because you were thinking about how disappointed you were it wasn't science. Okay, but it's okay because it's maths. And then you're really excited. All right, so you sit down and you spend all day doing your maths work because it's so much fun. All right, so that's you working. Okay, so you can see from this distance time graph, there are times when the graph is changing and times where the graph is not changing. All right, so where the graph is going up, that's you moving, and where the graph is flat, that's you not moving. Okay, so you need to make sure you understand that. All right, so for example here, graph is flat, therefore not moving. Okay, and then here, graph is steep. You are moving fast. And here, where the graph is not steep, you are moving slowly. Okay, so those are the three important things that you need to know about these kind of graph is when it's flat, you're not moving. If it's steep, it means you're moving really fast. And if it's not steep, it means you're moving slowly. So you can see that these distance time graphs can be used to, it's almost like they can tell a story, all right? And you can understand how people are moving around and how long it takes them and how fast they're moving and, or how long they're spending eating breakfast, all right? Now this is the lockdown version, so let's do a non-lockdown version, all right? So I've got here, so this is my non-lockdown version, all right? So this is, we've got our time in minutes on the x-axis and our distance in kilometers on the y-axis, and this time we've got two lines, all right? Because there are two people involved in this story. So the first person in this story, that's the blue line, that's me. And the second person in the red line, that is Mr. Paul. All right, so, and what this shows is on a Friday afternoon, after school, after you've all gone home, me and Mr. Paul, we're at school, okay, and then we like to drive to do the latest exciting science-related activity on a Friday afternoon, all right? And that exciting science-related activity is 5 kilometers away, okay? Now you can see that we both get there in 60 minutes, but the way we get there is slightly different, all right? So what are the differences in our journeys? Well, at the start, you can see that because I'm the blue one, all right, I set off really quickly, all right? I'm really excited about getting out, getting away from school, all right, towards the science-related activity. Mr. Paul, though, Mr. Paul's a very safe driver, okay? So he takes it a little bit slower, very nice and careful, okay? And then what happens is, because I'm really fast, all right, what we've got is here, there are a set of traffic lights. Now, I end up going straight through the traffic lights because they're on green, so I don't stop. However, Mr. Paul, he gets there when they're red, so he ends up having to stop at the traffic lights. All right, so that's why Mr. Paul here isn't moving, okay, because he's waiting at the traffic lights. All right, and then after that, there is another stop here, all right? So let's say here, I have to stop and get petrol, all right? So I stop for petrol. All right. Now, Mr. Paul, he stops as well, but he doesn't stop for as long. Okay, so he's not stopped for petrol. He's stopped to get himself stopped for, what would he get? He might get himself a nice bag of crisps. Stop for bag of crisps. All right, and that's why he hasn't stopped for as long as I've stopped for. Okay, now, after having his bag of crisps, Mr. Paul, he's all full of energy, he's really excited now, so he starts going really fast, okay? And he overtakes me because I'm now going much slower than I was before. And the reason for that is that I'm thinking about this really interesting maths problem, all right? And it's really got me thinking hard. And so I'm driving a little bit slower so I can think about the maths problem a bit more, all right? Which you shouldn't do, you must concentrate on the road, okay? So that's why I'm going slower, all right? And then I stop here. Okay, now Mr. Paul didn't have to stop here, but I did. So why did I stop here? And that's because as I was driving and thinking about my maths problem, okay, I saw Mr. Webb. And I thought to myself, well, if there's anybody that can help me with my maths problem, it'll be Mr. Webb. Okay, so I stopped to speak to Mr. Webb about maths. All right, now Mr. Paul, he was going really quick and he realised maybe I'm going a little bit too fast here, so he starts to slow down a little bit, drive a bit more safer. And then once I've spoken to Mr. Webb, I've solved my maths problem, so now I don't need to be thinking about that, I'm not distracted anymore, and I can carry on driving as normal. So you can see that there are parts of the journey where people are going fast, parts of the journey where people are going slower, and parts of the journey where people aren't moving at all, where they're stationary. Okay, now, the graph doesn't just let us understand how the journey unfolded, it also allows us to calculate certain things. All right, so if you'll remember that speed equals distance divided by time. Okay, and at any point on this graph, the gradient, all right, is the speed. So if I calculate the gradient of any point on this graph, I know how fast I was going at that time. All right, so let's ask ourselves the question. How fast are both teachers driving in the first 10 minutes? Okay, so in the first 10 minutes, Mr. Paul travels 1 kilometre. And it takes him 10 minutes. Okay, so to work out the speed, we do this number here, which is the distance, 1 kilometre, divided by this number here, which is the time. Okay, now I'm not going to do it in minutes, I'm going to convert that into hours. Okay, and to convert that into hours, I need to do 10 divided by 60. So it is 0.17. Okay, so it's 0.17. So if I do that calculation now, it is 1 divided by that number, I get 6. 6 kilometers per hour. Very safe driver. Very, very safe driver. Okay, so if I were to do the same calculation for me, all right, I've travelled 2 kilometers in the same amount of time. So you can work it out, my speed will be, well, because I've gone twice as far, I've gone twice as fast. So my speed will be a very fast 12 kilometers per hour. All right, and you can do that for any part of the graph. Okay.